Hi guys, today we're going to talk about pyramids and how to find the surface area or lateral area and the volume of a pyramid. So we need to get familiar with a few definitions. A pyramid is a polyhedron in which one face can be any polygon. That would be the base. That one face that is the base can be any polygon, and then the lateral faces are triangles. So it's a big deal to notice the difference between pyramids and prisms. The lateral faces of a pyramid are triangles that meet at a point called the vertex of the pyramid, and the altitude is perpendicular segment from the vertex to the plane that contains the base. Remember that we're going to use those terms, altitude. The altitude is the segment itself, but a lot of times we're going to talk about the height and altitude kind of simultaneously. Remember that the height is the length of the altitude, but frequently you're going to hear me say height instead of altitude. And a regular pyramid is a pyramid whose base is a regular polygon. Do you remember what a regular polygon is? Remember that a regular polygon has all congruent sides and all congruent angles, right? All sides are congruent, all angles are congruent in a regular polygon, okay? The slant height of a pyramid is the length of the altitude of a lateral face. So in a sense, it's like the height of one of your triangles. And so in this diagram, we're going to talk about all of these pieces a little bit, and we'll talk about the fact that we might call this a regular pentagonal pyramid. And obviously we're going to talk about these parts up here, and we'll say number one, that's the vertex of the pyramid, right? That's the point where all of the lateral faces meet. Number two, right over here, this is the slant height. And we won't use the letter H to represent the slant height. We're going to use the letter L, like a script L, to represent the slant height. That will be one of the altitudes of your triangular faces, the lateral face, right? Okay. And then 5 is going to be called the height of the pyramid. Or if you want to talk about it in terms of the segment, then it would be the altitude of the pyramid, but we're going to call it the height of the pyramid. It'll just be easier to distinguish that way. And then 4 is one of the shaded region that you see is one of the lateral faces. That's a lateral face. Notice that it is triangular in shape, right, as opposed to the prisms that we've studied. And then down here at the bottom that I've labeled as 3, this is pointing to the apothem or apothem, whichever way you say it, of the regular polygon base. It's pointing to the apothem of the regular polygon base, because you're going to need to find that or use it pretty often, right? And what I want you to notice in this particular diagram is that you should, within this pyramid, see a right triangle being formed by the height of the pyramid and the slant height in blue and the apothem of your regular base polygon in purple. And we're going to take those things and pull them out, because often you might only have 2 of those pieces of information, but maybe you need the other one. So what I'm going to do here is I'm going to take each of these out, a copy of each of these out, and show you where they would be if we were to have that triangle separately. Here's where your height would be, right here, right? And this slant height would be over here. We'll see if we can fix that a little bit. And the apothem will be down here at the bottom. Okay, so we'll see if we can adjust this a little bit. Put it over here. This is where your slant height would be in this triangle. And then the apothem would be over here, the apothem of the base. And those, remember that whenever you're missing 2 of those, you can always find the 3rd piece using the Pythagorean Theorem, and that's going to come up a lot. So we'll see how that applies coming up in the next few examples. Let's take a look. If you were to take your pyramid apart, almost if you had made it out of paper and you were going to unfold it a little bit, this is what your parts would look like. And we'll see if we can kind of show you. Here's a pyramid that has a square base pyramid, so we used S to represent the length of that side. notice, okay? And we want to talk about these formulas that you can use to find the lateral area or the surface area or the volume of this particular pyramid. So the lateral area is found by taking 1/2 of the perimeter times the slant height. And remember, the slant height is going to be the height of one of those lateral faces, right? So the slant height is going to be right here. Here's the slant height, right? And we're going to take 1/2 the perimeter times the slant height. So why would that be if we were wanting to find the lateral area? And the lateral area is what you see in kind of this bluish color over here. The lateral surface are the triangular faces, right? And how do you find the area of a triangle? The area of a triangle is 1/2 base times height. And so the lateral area is 1/2 the total perimeter of your polygon base times that same height. So essentially, if you really prefer, you could just find the area of one triangle and multiply it by however many triangles you have. That's the exact same thing when you're finding the perimeter. That's the exact same thing. So if you prefer to just find the area of one triangle, and obviously if you have a square base pyramid, you're going to have 4 triangles, and if you have a pentagonal base pyramid, you'd have, like in the previous page of notes, you would have you'd have 5 triangles, right? And so you could just find the area of one and multiply by 5 to get the total lateral area, or you could just do 1/2 of the perimeter of your base times the slant height, if you prefer. And the surface area then obviously is going to be the sum total of all of the areas of all of the triangles, all of the lateral faces, plus the area of the base, right? And the area of the base is shaded in green here. It's a square base, but it could be any polygon. You just don't know what shape it's going to be. It might be a triangular base or a hexagonal base. And the volume of a pyramid is given by 1/3 BH, and B stands for area of the base. So let's maybe clarify that in each of these formulas. Capital B is area of the base polygon, right? Whatever shape that may be. And H is height of the pyramid, which is not the same as the slant height. So I'll go up and clarify that up above here when we talk about lateral area. The P here stands for perimeter of the base polygon, right? And the L, the script L, is for slant height, right, which is one of the heights of the triangle. And then again, when you're talking about surface area, the P and the L are the same thing, perimeter of the base shape plus the slant times the slant height. And then capital B, remember, is area of the polygon base. Whether that's a square, typically, obviously, a lot of them are squares. Square base, triangular base, hexagonal, pentagonal base, could be any one of those. And that volume of the period, the 1/3, really comes from a relationship in Cavalieri's principle, which I'm not going to discuss here. In your text, I think it's on page 516, 517, where the volume of solids is compared, and so that you can compare the volume of a pyramid to, say, the volume of a cube, if you could snugly fit the pyramid inside a cube. So we're going to find the surface area and volume of this square base pyramid shown with a base edge of 12 centimeters and a height of 16 centimeters. So notice that in this particular problem, the height is not actually shown. So I'm going to draw in the height. And let's see, we'll go ahead and make it red and dashed. And we'll put the height right here. So there's going to be your square base. Excuse me, that's your height and your square base. And we're also going to need that apothem. Obviously, we're going to need the apothem so that we can say, all right, well, what if we need the slant height? Because we don't necessarily know what that is, right? All right, so let's put in the length of the base edge. This would be 12 centimeters from edge to edge here, corner to corner. There is 12 centimeters. That's a base edge. And then this height, 16 centimeters, is from the vertex of your pyramid perpendicular to the plane that contains the base. And so there's your height, right? And if we want to find the surface area, remember that surface area is equal to lateral area plus the area of that one base. Now we're talking about figures that only have one base instead of two. Remember that our lateral area is going to be 1/2 the perimeter of the base times the slant height plus the area of the base. And here's something, let's talk about this right away. Let's deal with this fact right away. So let's come up here and talk about this base shape. We have a square base, so our area of the base is going to be equal to s squared, which would be 12 squared, which would be 144 centimeters squared. And let's just knock that out right away so that we can identify everything we need to. Maybe we can go ahead and take care of some other things as well, right? So maybe we should. Let's go ahead and take care of some other things as well. We have a regular polygon base, right? We already know that the area of that base is 144 square centimeters. Let's go ahead and figure out the length of the apothem, right? The apothem in a square, that's the easiest way for you to figure out the apothem. You know that the apothem should be half as long as the sides. So the apothem in this case is going to be 6. We're going to do another problem where it's going to be a little bit more challenging, but in this case it's going to be 6 centimeters. And we have the height given as 16 centimeters. What we don't know is this. We don't know the slant height, right? We don't know what is L, which is the slant height. That's what we're looking for. Let's go ahead and figure out what that is. So how do we figure out what that is? Notice, remember, I don't know if you recall, but on the previous page of notes, we made a right triangle, and we had these parts of it. We had the components, the height, and we had the apothem in purple, and then we had that slant height, right? So that's the slant height that we're looking for right there. This is something that's unknown, correct? So we're going to go ahead and figure out what that is before we proceed with doing everything else. And do you remember how to do that? You should be able to use the Pythagorean Theorem. So 6 squared plus 16 squared is equal to L squared. 36 plus 256 is equal to L squared. And then 292 is equal to L squared. And you can take the square root of both sides. We're just going to go ahead and leave this for the moment. Well, we can simplify it. So if you simplify the square root of 292, 4 does go evenly into 292, goes 73 times. So then you can get 2 square root of 73. We're going to use this exact values as much as possible for a while. So now we have the slant height, and we have the area of the base, and we should know the perimeter of our square base is the length of one side, 12 centimeters times however many sides, which is 4, right? Okay, so now I think we have everything we need. It's a good idea to go ahead and plug in whatever we possibly can whenever we can. So now we found the area of the base to be 144 centimeters squared. The perimeter should come from 12 times the number of sides, which is 4, and the slant height is 2 square root of 73. If you want to cancel, it's probably just easiest to cancel those 2's right there rather than multiplying first. And then you're going to get 48 square root of 73 plus 144 centimeters squared. And that's your surface area as an exact value. If you want to get an approximate value, you could type that into your calculator. 144 plus 48 square root of 73. And your approximate surface area is 554 centimeters squared if you're going to round it to the nearest whole number. Remember that you just don't know. You're going to have to pay attention to whether or not your teacher, your program, whatever assessment you're doing wants an exact value or wants an approximate value. And you got to be prepared for either one. Now let's figure out the volume, right? So volume is equal to 1/3 area of the base. Remember that this is base area, right? Times the height of the pyramid. So we have 1/3. We already found the area of the base. I don't know if you remember, that was 144 centimeters squared. And the height of the pyramid was given as 16 centimeters. 3 does go evenly into 144, and that's going to be 48. And 48 times 16, a lot of different ways that you can multiply that together. But 48 times 16 is 768, and this is going to be cubic centimeters for the volume. And now you're done. So it's probably the best idea if you're going to find, if you don't have tons of information given and you might have to find all of these components, it's probably a good idea to go ahead and figure out what is your base shape, what is that area, what's the length of the apothem, what's the height, because you need the slant height, you need all of these things, right? So this was 2 square root of 73 centimeters. And it's if you just start off with that and put all of those at your disposal, then you can calculate whatever it is you need to calculate. All right, let's move on to the next problem. Let's talk about the Great Pyramid at Giza in Egypt, built about 2580 BC as the final resting place for Pharaoh Khufu. At the time it was built, its height was about 481 feet, and each edge of the square base, and it's a square base, was about 756 feet long. You certainly can't tell by looking at this photograph that it's a square base, so we have to have that knowledge given to us, right? And we are told the height of the pyramid, which obviously would be from top to bottom on the inside that you can't see. That's not a slant height, that's the height of the pyramid, okay? Okay, and we want to know what is the lateral area. This is what's unknown. So let's think about what we need for the lateral area. Lateral area is equal to 1/2 the perimeter of the base shape times the slant height. So the perimeter of the base shape, that's not really challenging for us to find, right? We can tell that this was known to be approximately 756 feet long. So that shouldn't be so bad. That's 1/2 of 756. Remember that it was a square base. So we have 4 sides to that square base times the slant height. That's the bigger question right there. So now we need to figure out what's the slant height. So how are we going to do that? Remember that the slant height, that slant height, and if you're not sure, then the slant height squared is going to be equal to the height of the pyramid squared plus the length of the apothem of the base, also squared. So we're basically just pulling that triangle out and saying, here's the 481 feet that we know is the height. That's h, right? And that apothem right here, if we take 756 and divide that by 2, then we get 378, and we're looking for the slant height here. So L squared is equal to, the height of the pyramid was 481 squared, plus the length of the apothem of the base is 378 squared. So L squared is equal to, so I'd probably just type those into my calculator. I'm certainly not going to do that by hand. That's definitely a waste of your time for the most part, you know, unless you're in elementary school where multiplying is something a little more critical for you to master. And then when you get the sum, you get 374,245. And you should maybe check it, see if it is a perfect square. If it is a perfect square, then I'd record it that way. And if it's not, then I'd probably just record it as the slant height is equal to the square root of 374,245. And I would leave that. I'd probably leave that in the problem that I'm working temporarily until I get to the point where I'm ready to approximate. Why? Because you don't want to approximate too soon. You have more margin of error when you approximate too soon. And in this case, we're just going to wait to approximate at the end. Okay, so we have 1/2 of 3,024 times the square root of 374,245. So you get 15. If you take half of 3024, you're going to get 1,512 square root of 374,245. Now I'd probably go ahead and approximate that and say that the lateral area is approximately 924,975 feet. Excuse me, squared lateral area. It's still square units because we're talking about essentially what would it take in essence to think about if we were you know, filling, shading, or covering every single of one of those triangular faces of the pyramid in a sense, right? Okay, let's try something a little bit more challenging. We've been dealing with square bases. What's going to happen now when we talk about something with a more challenging base? Again, we want to find the surface area and volume of a regular hexagonal base pyramid. This is something that's a little bit new and different, a hexagonal base pyramid with a base edge of 4 inches. So we'll put 4 inches right there, and a slant height of 9 inches. So we'll go ahead and draw that in here with a slant height of 9 inches. So I'll just put that slant height there, and we'll label that L equals 9 inches. Okay, now we got to talk about, remember, if we want the surface area and volume, then obviously surface area is lateral area plus the area of the base, right? So that's 1/2 the perimeter of the base shape times the slant height, which is great. We have everything we need there, but we don't know what the base area of this polygon is. So here's what I would really recommend. Again, you really want to think about what is the shape of my base. We had to do that with prisms, and you really need to consider continuing that even more so with pyramids and every other shape that you're studying a little bit. So we know that the edge of your hexagonal base is 4 centimeters, right? And we want to figure out, if we want to find the area of this hexagonal base, then obviously we're going to need to add in, we need to see where the center of that would be, kind of approximate that. And we want to put in the apothem, right? The apothem right here. We need to know what that is. Because why? Because we're looking for that area of the base, right? This is a hexagonal base, and in this case, we're going to do 1/2 of the apothem times the perimeter, but we don't know what the apothem is. So that's why we drew that radius in there. And remember that this is 30 degrees up here in a regular hexagon, and this is 60 degrees. We've talked about why that is multiple times. So if you need to go over that again, you got to contact me. So opposite the 30 would be 2, and opposite the 60 would be 2 square root of 3 from your special right triangles, 30, 60, 90. So now we know the length of the apothem is 2 square root of 3, and the perimeter should be 4, the length of one side, times 6 sides altogether. So let's go ahead and cancel those 2's, and then you can say that that base area is equal to 24 square root of 3 centimeters squared, and that's what your base area is. So let's go ahead and put that right here, 24 square root of 3. And notice we already had the perimeter, that was the 4 times 6, and the slant height, I'm going to have to move this over here, let's move that over, and then the slant height was known to be 9 inches, right? All right, so you can go ahead and cancel, cancel the 2 with that 4 and make that a 2 if you wish, and then we can say that this is going to be 12 times 9 plus 24 root 3, and that's going to be 108 plus 24 square root of 3, and that'll be centimeters squared for your total surface area. And then if you need to approximate that on your calculator, you should know how to type that in. Let's go ahead and find the volume. Volume is 1/3 area of the base times the height of the pyramid. Remember that that capital B is area of the base shape, and that's a big deal, right? And that H now in this case is height of your pyramid, right? Different from your triangles and parallelograms and rectangles. So 1/3. We already found the area of the base shape. If you don't remember, we did that up here. Here's the area of the base shape, so we're going to use that again. That was 24 square root of 3 times the height of the pyramid. Whoops, we don't have the height of the pyramid. Okay, so it looks like we got to find the height of the pyramid. Remember that in order to do that, what we're doing is we're using the slant height as the hypotenuse, and we're using the apothem, 2 square root of 3, that was, I think, maybe in purple, as one leg, right? And we are still missing the height right there. So let's figure out what that is. H squared plus 2 square root of 3 squared equals 9 squared. So H squared plus 12 equals 81. H squared is equal to 69. Take the square root of both sides, and H is equal to the square root of 69. So we'll put that right here. All right, we're going to cancel what we can cancel. So this 3 cancels with this 24 to give you 8. So now we have 8 square root of 3 times the square root of, why don't we break this down a little bit, because we know that that's 3 times 23. And if we do that, then we can express this as 8 square root of 3 squared times 23. And then you know that if you have 2 of the same factor, you can take that out and have it represented by a single 3. So 8 times 3 square root of 23 will result in 24 square root of 23 inches. Were we measuring in inches? Whoops. We were measuring in inches, and I didn't put the same units, excuse me, on this picture. So let's make sure we fix that and change that to inches here, and change this also to inches here. That way we can have the right unit of measurement, 24 square root of 23 inches, cubic inches for our volume. And that should hopefully cover everything we need to know to be able to find the volume and surface area and lateral area of a pyramid. Just keep in mind all of the critical components that you need. You probably need to have the slant height. You probably need the slant height, and you need the height of the pyramid, which I didn't include in this diagram, and you need the length of that apothem right there, okay? So please make sure you get all of those things, including the area of the base shape. And that's the end of surface area and volume of pyramids.